In this video, I want to talk about the paper precision detection in dense packed things. These authors did a wonderful project. In the old algorithms, most of them can only detect objects with some errors. But in this algorithm, the author can detect all the objects very precisely and give them with the bounding box. And if there's a missing object, there won't be any bounding box here. First, the author reviewed some old algorithms and old datasets. These image datasets, they have less objects per image and less classes per image. But the author created a new dataset which has 147 objects per image and over 110,000 classes. And for every image, it belongs to 68, 86 classes. And most of those previous data sets don't have the dense packed objects, and they don't have too many identical objects. But this author, this image set combines everything together. So everything is dense and have identical images. So first, the author reviewed all the old algorithms for the object detection, and finally they used the RetinaNet as their base algorithm and add some new features to it. Actually, this is what they added here: the soft intersection over union layer. First, they use the old algorithm to detect the bounding box and the object in the image. And for this intersection over union layer, the author used it to detect objectiveness, which means if the bounding box really have an object in it, because maybe the old algorithm can identify the empty space at one of the objects, but when we add this layer, they can exclude the empty ones. After that, the author used the expectation maximization algorithm, which gave them a lot of Gaussian filters and try to find the optimized Gaussian filter. A lot of mathematics here, and which is very hard to understand. But the whole concept is that because we give them different Gaussian filters, we can try to find only a couple of the most fitted Gaussian filter, and then we create the only one bounding circle here. And the final output of the bounding box is based on this bounding circle. And the result is here. Yeah. Well, the RetinaNet is their base. So in this picture, the higher the lines the line is, the better the result. And for this picture is when the lines are getting lower, the results are getting better. So we can see when they add different methods, add a new layer or add a expectation maximization, they can move the lines up, and here they can move the lines down. So the result looks pretty good. And this is image detection, the old algorithm and the new algorithm. We can find that here the old algorithm have a lot of overlaps, but the new algorithm it doesn't. And here, the old algorithm may divide uh, the one object into several, actually more detailed parts, but that's not what we want. In the new algorithm, they only have the one package at the bounding box. And that's it. Thank you.